In this video, we are going to talk about how to graph log functions and how it relates to exponential functions. So we've talked a little bit about logs and what they mean and how they relate to exponential functions. And today we're going to talk about how we graph. So we're going to be using Desmos. So make sure that you have desmos.com open, and we're going to be using that to help us graph log functions. So the first thing we're going to do is we're going to review how we graph exponential functions. So let's type this equation into Desmos and get a table of values for this function. And then we're going to go to our settings key, make a table. Okay, so I'm going to take these values, I'm going to copy them into the table on my notes, and then I'm going to plot my graph. So 0, 1, 1, 2, 2, 4. Okay, so when we graphed exponential functions, remember our asymptote was here at y equals 0. And then we would draw our graph. The domain for all exponential functions was negative infinity to infinity. This was always true. And then our range was bottom to top. So it would have been 0 to infinity. And this is always where our asymptote was. All right, now we're going to compare this to the graph for a log. So I'm going to change colors. And let's type this into Desmos and get our table of values. So I'm going to close these. To get our log button, we are going to go to our functions key over here on the right. And we're going to scroll down until we see calculus. So not all the way at the bottom, but about part of the way down. We want to select the one that says log A, not log A. And so we're going to do log base 2 of x. Oops. And let's get a table of values. So I'm going to hit my settings tool, get my table. And it looks like I have a lot of undefined points. So let's see, if I type 3, nope, I don't get a nice number. Let's try 4. Okay, so I'm going to stick with these 3 numbers. So 0, 1, so, all right, 1, 0, 2, 1, 4, 2. I'm going to copy those into my table. And I'm going to plot those points. So 1, 0, 2, 1, 4, 2. And our exponential functions and our log functions are opposites of each other. So my exponential function had an asymptote at y equals 0. And so it's going to be opposite for my log function. My asymptote is going to be at x equals 0. It's going to be a vertical asymptote. And so my function is going to approach my asymptote and then move away. And so what does this do to the domain and range? So if I'm thinking about my domain, I'm thinking about left to right. And so the most left side of my graph is here at x equals 0. And then the right side of my graph is going towards infinity. So my domain is going to be 0 to infinity. Oh, wait, that looks familiar. It's the same as my range from my exponential. So my domain becomes my range. Again, these are opposites of each other. Then if I'm thinking about the range, again, I'm thinking bottom to top. So my bottom here is going down towards negative infinity. And again, this arrow is going to keep going to the right and up. So it's going to go towards positive infinity. So negative infinity to infinity, which is the same as the domain from exponentials. So just like with exponentials, this is always going to be true. This number, the 0, is going to change based on the asymptote. So based on this. So let's do a few more examples. So I'm going to do log base 3 of x. I'm going to type this into the graphing calculator and get my table of values. I'm just going to click here and arrow over and change that to a 3. Oh, nope, I can't do that. Let's start over. So go to functions, scroll down to where it says calculus. Calculus, and we're going to select log A. We're going to do 3 of x and get my table. Now I have a lot of points here that I don't need. So I'm going to delete all these ones that are undefined. And I'm going to keep adding points until I get some nice points. Okay. So my nice points are 1, 0, 3, 1, and 9, 2. So I'm going to use those 3 points. So I'm going to use 0, 1, 3, 1, and 9, 2. And I'm going to plot those points. So my asymptote is still going to be at x equals 0. So it's going to be along here. And then I'm going to draw my graph. Oops, I missed. Try again. So the asymptote helps me determine the domain. So since my asymptote is at 0, my domain is going to start at 0. These will always be the same to infinity. My range will always be negative infinity to infinity. Now my x-intercept is where my graph crosses the x-axis, so that's right there at 1, 0. My y-intercept will be where my graph crosses the y-axis, which doesn't happen, so there is none. Okay, we're going to add in some transformations. So we're going to start off with our equation, log of some base. And we're going to have x plus or minus h and plus or minus k. So just like with exponentials, our number in here tells us whether we're going left if it's plus h or right if it's minus h. And then our k plus k is going up and minus k is going down. This base can be any number greater than 1. So 2, 3, 4, 5, etc. All right, so let's look at number 2 now. And first, we're going to talk about what the transformation is. And that comes from this minus 3 here. So if it's in the parentheses, we said that that's going to be left or right. Since it's minus 3, it's going to be right 3. So now our h also tells us our asymptote. Our asymptote will always be x equals h. So my h is equal to 3 because it's minus 3 here. So x is going to equal 3. So I can put that asymptote in at 3. Now, to plot my points, I am going to put the equation into Desmos, but I'm not going to put the whole equation into Desmos. I am going to, move these numbers. I'm only going to put log 2 of x. So you're just putting the parent function in, not the whole function. So to enter the log, I'm going to go to functions, scroll down to log base 2 of x, get my table. Again, I'm going to need some more numbers, so I'm going to use 1, 0, 2, 1, and 4, 2. So 1, 0, 2, 1, and 4, 2. But now I'm going to take these points and I'm going to shift them all right 3. So I'm going to start at, let's see if I can zoom in here. Okay, start at 1, 0, but then I'm going to go right 3. So this is where I started. So each of these points will be a little x. So right 1 and then right 3. Then I'm going to go to 2, 1, just here. Then I'm going to go 1, 2, 3. I'm going to do 4, 2. And then I'm going to go right. Oh, nope. Sorry, guys. 4, 1, 2, 3. Oh, 4, 2. Oh, I made a mistake. I'm sorry, guys. Hold on. Let's start over. 1, 0. And then right 3. 2, 1. And then right 3. I apologize. Now 4, 2. And then I'm going to go right 3. All right, so then I'm going to take these, I'm going to go along my asymptote and then draw it out. All right, so thinking about my domain, again, my domain is always going to start with the same number as my asymptote. So it's going to be 3 to infinity. That's starting here at 3 and it's going to infinity. And then my range is going to be starting at the bottom, so negative infinity to infinity. So again, my x-intercept is where it crosses the x-axis, which is right here at 4, 0. And my y does not cross the y-axis, so there is none. All right, let's look at another example. Now this one should have parentheses like this, or to show that this plus 5 is on the outside. So if it's on the outside, that means we're going up 5. And since that's up and there's no number in here, that means my asymptote is going to stay x equals 0. So let's get our table of values. So again, we're doing this for just the log base 4 of x. empty my table. And again, there's going to be a lot of numbers I don't need. So you can delete those or you can just ignore them. But I need a couple points. So I'm going to add a couple numbers until I get a couple that I like. So 1, 0. I could do 2.5 and then 4, 1. I could do 8, 1.5 if I wanted to. So let's do those. So I think 3 points is enough. And so I'm going to take those points, but then I'm going to move them all up 5. So let's draw in our asymptote first. So at x equals 0. And then we're going to plot these points and then move them up 5. So I'm going to start at 1, 0. And then I'm going to go up 5. 5. Then I'm going to do 2.5. And I'm going to go up 5. 5. And then 4, 1. And I'm going to go up 5. I did not mean to erase those. Let me put those back. I'm going to just extend this down. That was at 2.5. Okay. So again, my domain is always going to start with wherever my asymptote is. So 0 in this case to infinity. And then my range will always be negative infinity to infinity. And we're going to skip x and y intercept for these ones because we can't tell what they are. All right, we're going to do one more now with 2 transformations. So if I have minus x minus 1, that tells me we're going right 1. And then I have minus 2. So that's going to tell me that we're going down 2. So I'm going to get my table of values for log base 4 of x. Again, we're just doing it for just the parent function, not with the numbers. I think that's actually the one we just did. It is. So we can copy those same numbers actually. So 1, 0, 2.5, 4, 1. And then we're going to take all those points and move them right 1 and down 2. So 1, 0 is going to go right 1, down 2, right 1, down 2, right 1, down 2. Since my transformation is right 1, that means my asymptote is at x equals 1, which means my domain also is going to start at 1. So I can draw my asymptote at x equals 1. Connect my points. Your range will always be negative infinity to infinity. In this case, we can't see where the x-intercept is going to be. We could plug it into Desmos. We'll talk about how we find this later. And we're not going to have a y-intercept. So we'll just skip this for now.